Hello, who are you? I hear say una no one give person time to rest. Oh. Hello guys, welcome to another video of mine. Now we are going to be talking about Taylor's serious. Thank God that they use the word Taylor because the man talk like a Taylor. You know, you know say sometimes at least for at this December, I know say some of una so dress. I go meet Stella like this. Stella come bring out the measuring tape, come the measure on size and everything. Now, you tell make you raise your hand up, make you bring your hand down, make you all those things wey tell make you do. Uh, uh. So now waiting tell us see finish. Tell us saw this and then thought, okay, let me try to put it into mathematics. Let the thing frustrate some of our lives. People dey cry for exam hall say they no sabi how to do differentiation. You carry your own come. Anyway, you don give us now, you don go. Make we still suffer am. But whatever, the labour of our heroes shall not be in vain. Abeg. So the idea Taylor just did, that's what he just did. So wetin Taylor do be say, just imagine say they tell you make you draw graph of sine. Sine, yes, sine dey start from here. So this is how, let's say sine weighting. I don't want to call anything, but sine something, sine x. They say make you plot this thing graph. This is how it look like. Now, let's say we want to wear this our graph one way and small dress. So we go tell her make the thing raise hand up first, raise leg up first. We go come measure that particular part. When we measure that particular part, we will come get something we go down there like this. But the thing will not be exactly the figure of the whole body. You go notice say you get some important place where you guys measure. Those places when you measure them, other places you no fit measure them because of, you know, say if you just get that part, you fit just assume wetin the other parts size be, or maybe you know, I don't know. Tell us go understand my, this na tailoring topic. So use tailoring ideology now. You wey sew dress for December, wey no sew for me. Now you cause all this thing. So they will measure your ribs and the rest of them, understand? They will not come be measuring every single segment of your body. You get some part they go measure, leave the other parts. Still, when they sew the dress, the two go enter your body, but it no go come become skin fit, no go come become tight clothes to your body. So now wetin Taylor do? So if someone could plot graph wey that's like this, sine x, and it looks like this, Taylor is now thinking of a way to create another function out of this. This function will have almost, I say almost to almost the same properties as this sine x. So this is a quadratic equation because the thing is a curve. So this might be something like, let's say x squared plus 3. That's what this our, I'll use one, not sabio. That's what this our second graph is now representing. So you notice that to a particular point, this our graph is matching that sine x. The thing can't reach here, can't understand, can't they go where they go. So that is what Taylor is all about. So the more you measure, so if you got Taylor, so you want skin tight, you will keep on adjusting the graph small. Maybe if you adjust this part, adjust them, make it just run well with this one, can't give you like and that one again. just like that. So that's what Taylor did. That was just the whole serious idea. So the more serious, or the more of the serious that you try to get, you are trying to make the new formula you're deriving to match the one given to you. I don't talk too much, bros. No could solve this question where they give us. If you don't get it, no. I beg, get them, get them. No, no, why, no. So, solution to our question. Our question says solve y bar. You know, say y bar. Now dy dx. Y bar is what? Dy dx. Dy dx. Going to be y bar. Okay, so y bar is equal to it x plus y, comma y of 0 is equal to what? 1. This y of 0 is equal to 1. This is also something as you say y is equal to what? 1 when x is equal to what? 0. So they are telling you that when x was 0, you put it into the function of y, it will give you what? 1. But that function we no sabi. That's the issue now. We no sabi the function. But whatever that function is, if we impute our x equal to 0 into it, it will give us what? It will give us that our y is what? 1. Now, what this thing mean? So, by Taylor's series method, hence, find the values of y at x equal to 0.1 and x equal to what? 0.2. Okay, so when we solve problem na when they call us engineer. If we dey for house dey chop indomie, we no be engineer. We will solve am. At least before today end like this, person fit come engineer for road. Na small thing, na small achievement. Okay, so okay. So we want to use Taylor series. Abeg, make I write Taylor series formula. Make we just write am down. So for whatever y we are trying to find, like for example, they say we should find the value of y when x is what? 0.1 and x is what? 0.2. So for whatever each of the y you want to find, the formula is y is equal to that way where you want find is equal to the initial y given to you. In our case is what? Y. This is I beg my small thing here now. Initial condition. That's the first values where they don't give you, or the first value of x and y where they don't give you. Our initial condition is what? Y equal to 1, x equal to what? 0. Initial get alone now. So that's our initial, this one. We will then add it to x minus our initial x. In this case now waiting 0. Multiply by y prime, which is this stuff where you just see here. You multiply it by what? Y prime. Now this, you also add this to what? X. The x I talk about here now, this x where they give us. So this x we don't get 0 is this x and this x. So whichever one you're solving with, you impute this value to replace it. So you subtract it from what? The initial x. Again, this time around you square it, and then you then multiply it with double bar. of y. That means you go differentiate this thing again. You don't differentiate them already, but you go still differentiate them again. That is the second order over what? 2 factorial. I beg you, make factorial not confuse you now. We don't do factorial before. When we are doing what do they call that topic? But I don't forget to. I don't forget. Factorial. I thought factorial from one of my video now. Try this thing. Now Christmas rice, so they don't they showcase the effect now. Okay, so minus x 0 3. Now this power was 3. So as you notice, as we are going, it will be what? Increasing. Now you can also get this one, so it's not going to become triple what? Bar over 3 factorial. If you do another one for 4, the same thing. And so you could do a to you reach any number where you will say make you stop. You call that number any. So x minus initial x or which should have given to us raised to power what? Any multiply by y raised to power what? Any over waiting. This is not be raised to power. This is not differentiation, understand? Into any times. So you have differential. This is the any. They call this one second order. So it will be nth order differential equation. So over what? Any waiting bar. So that's how you continue to your land there. So the series not the end. I want to with them. So the more skin tight clothes where you want, so they tell you they measure that segment of your body. But if you don't want too much skin tight, you go they understand. So that's just the idea here. That's just the idea here. So using this formula, at least from the formula don't tell us say we guys get some few things. We know our initial y, which is what? 1. Know our initial x, which is what? 0. We don't know. Okay, we know this one, which is what? X plus y. Well, we need a value. So we're going to substituting this thing that we don't get now. We'll substitute into this one. Get our answer. Now what else? The same thing this one. You go differentiate again for this one. So you could do to a particular this thing approximation where you want stop. So now you know the kind of size of, if you want body hug dress, now you go sabi where you go like stop. But let's say for this one now, I go like stop at the 4th. I go like stop at the 4th one. So I feel just clean this one. Let's stop at the 4th approximation. If you continue, the more you continue, the more closer you are to your answer. So our aim now, what we want to focus on, what we're trying to focus on now is to get now our y prime, y double prime, triple prime, and the 4th prime and the bar beauty. So for our first one, which is y bar, they told us is what? X plus y. Now x plus y, our x is what? Our x is what? 0. Our y is what? 1. This is equal to what? 1. So 0 plus 1 and 1 now. B. So to the next one, engineer, maintain. To the next one, we're going to be differentiating this one. Differentiating this one now in respect to what? X. So for the first one, if we differentiate this one, we have what? X. I'm correct now, right? If you differentiate this baba way there, we will get in respect to x. We have 1, no verse. We have 1. So remember, I say differentiation now. If you are giving, let's say x, just ask yourself wetin be the power. In this case our power is what? 1. Though they know the right time, but our power, we know our power is 1. That one you subtract 1 from it, and that same one you also multiply it in front of your x. So when you subtract your 1 minus 1, you have what? X raised to the power of 0 times your 1. Anything raised to the power of 0 now waiting. Now 1. 1 times 1, 1. So now I don't want this differentiation. It is going to take us to Garden of Eden. I've been to Genesis, understand? So I no wan go there now. So this plus our y, when we differentiate our y with respect to x, we are going to be having what? Y prime. And we got our y prime to be what? 1. So when we substitute, we'll be having 1 plus our y prime, which is what? 1. We have answer to be what? 2. Sure? Now, moving over to the next one, which is our what? Y prime prime prime. We want to differentiate this guy again. Now, when you differentiate a constant, definitely to give you what? 0. You add it. Now, differentiating this guy now in respect to x, since it is not x, you're going to be having what? Y double what? Prime. And we know that our y double prime is what? 2. So when we add it, we have what? 2. For the fourth one, when we differentiate this guy, so this thing feels so good. If you also have waiting 0 plus something, that thing, so you can still write this like this. So when we know the two we'll see the 0 or something. So differentiating this guy now, we are going to be having what? Y prime prime prime, and we will have our answer to be what? Simply 2. Or y prime prime, we got it to be 2. Differentiating this guy. Also, it's really confusing now. So may I repeat them again? When this was already given to you, this, I just transfer and come here. Substitute our initial values, put into this stuff, got an answer. Now differentiating this x plus y, I got 1 plus y bar. When you differentiate y in respect to x, you get what? Y bar. Y bar. Okay, so when you differentiate it, you have 1 plus what? Y bar. Substitute your value of your y bar, which you have gotten previously, to be 1. Substitute it here, you're having 1 plus 1, which is what? 2. Which is what? 2. Coming over to the next one, when you differentiate 1, you have what? 0. Or any constant, if it be 2, if it be 3, when you differentiate them, you have what? 0. Now 0, you add it to, when you differentiate this one, now we call what? Y bar bar. What will be your y bar bar corner? We have gotten it before to be what? 2. You substitute it. So you have 0 plus what? 2 to be what? 2. Coming over to this one. When you then differentiate this guy, you have y bar bar bar. Bar raised to power. I be bar 3. 3 bars. Baba. Anyhow you want to put a column. So like that, which is this. You understand? So we have gotten the values that we need. So we can also write this in somewhere, just create small space, because I'll do go use some of our distance. So for y bar, we are having it is equals to what? 1. Y bar bar, we have what? 2. Y bar bar bar, we have what? 2. And last but not the least, we have what? 2. Okay, so we have gotten this. Now it's now kunye make a formula. Give me answer. That is what is left for us to do. Do it and get your what? Answer. Now, remember, we are going to be solving for the first one now. So for when x is equal to what? 0.1, y will then be what? Our initial y is what? 1. Remember, this y0 initial y, initial condition at that time here, 1. You add it to x minus x bar. What is your x in this case? 0.1. You minus it from what? Your initial x, which is what? 0. This. You understand? I never done any magical. See what I just dey do. So this. So for this one, y bar, we have gotten the answer to be what? 1. Substitute it again, we'll be having what? 1 plus x. We said is what? 0.1. Subtract it from your initial condition, 0. Initial condition. I just add this in 0, 0. Maybe don't confuse people. Maybe that too. Okay. Now, raised power what? 2. Multiplied by what? Y bar, which we got to be what? 2. Over to the next one. Okay, sorry, we omitted something. Over what? 2 factorial. Remember what factorial is now? When you are having 4 factorial, it means 4 times 3 times 2 times 1. You have to multiply this to get the answer. I think the answer is what? 24. So for 2, the same thing. This is for 2 factorial. So 2 times 1 is what? 2. So 2 factorial is what? 2. Okay. Now we add it again. Our x 0.1 minus x bar 0. This power was 3. Y bar. We have it to be what? Y bar now waiting. Okay, so here 2 over 3 factorial, which is 3 times 2 times 1. So we add this to this is what we are now. This. So we add it to what? 0.1. Remember where our 0.1 came from is here. Okay. Minus raised power what? 4. Multiply by what? 2 over 4 factorial. We have 4 times 3 times 2 times what? 1. You grab? Okay. So wake up. Okay, so when you they do me now, why my brain they process like this? Okay. We have gotten our answer. So just simply solve now the goals. They don't substitute everything now. So na felele wayele. Don't make mistake. So 1 plus 0.1 minus 0 now. 0.1. You multiply by 1, you have what? 0.1 plus with calculator. We will solve this stuff now. So we have 0.1 square times 2 over what? 3 times 2. Yeah. So we have gotten the value for this. Now over to the next one. Calculator. You have 0.1 raised to power what? 3 times 2 over 3 times 2, which is 6. That's for this. And we're going to be having our answer to be 0.0003. Okay, so this is where you're going to stop. Your calculator will give you 3.3333 times 10 raised to the power minus 4. So this is the decimal form. 4 zeros in front. So for the fourth one, we have the fourth one we have 0.1 raised to power what? 4 times 2 divided by what? 4 times 6, which is 24. That's for this one. The whole of this is 24. And everything will give us 0.000083. So when we add all these together, we have 1.1103 approximately. Okay, so this is what we get as y when our x is what? 0.01. This is our what? Our y value. We have gotten it for when x is what? 0.01. So we have gotten for this one. This is our value. So they gave us 2x. They say one no go do us. They want make we work hard. They give us two values of x. So I've gotten for the first one. The second one now. Let's also try to get it. Our second one is okay. I'll clean this. There is no need cleaning the whole thing. This is just the same step. So for the next one, so when our x is now was 0.2. Now this thing can change this to 0.2. Then our values for this one will change. This one will change. This one will change, and this one will change to what? 0.2. So 0.2, 0.2, and 0.2. So shall you grab? So we are waiting for x when it's 0.1. We have gotten the answer. That one now first now I. So we are moving to I now, which is when x is what? 0.2. Now when x is what? 0.2, we have imputed it in this formula, and every other thing that we have gotten earlier. So let's not write our final answer. Our final answer will then be 1 plus, not final answer, let's do this off. So this times this is going to give us 0.2 plus, for the next one we have 0.2 square times 2 over what? 2. And we have 0.04. To the next one, we have 0.2 square cube times 2 raised to power 6 times 2 divided by 6. We are having 0.0002667. Over to the next one, plus, which is the last one. We have 0.00013. Now, adding all this, we have 1 plus 0.2 plus 0.04 plus 0.00267 plus 0.00013. So we have our final answer to be 1.2428. So the value of our for y when x is what? 0.2 is 1.248. Kai, finally we are done. So we have gotten the other parts, and that's all for this video. So the Taylor series is just series of approximate value of your, but I not speak too much grammar. We are done. Please subscribe to the channel, comment, like, do everything you can do to help your lovely brother. See you in the next video. Goodbye.